In this presentation we're going to look at probability tables. So we're going to first off look at the question, and that is as follows. Research was carried out on the number of flights leaving a particular airport last year. Of 170 flights that departed on a particular day, 107 were to destinations within Europe. I'm just going to sort of point out there that that means that 63 went outside Europe. Okay, so very quickly we'd look at the fact that the complement event. So if they went inside Europe, 107 went inside Europe, 63 went outside Europe. Anyway, of all of these 170 flights, 36 were delayed. And again, what we're going to think of is that means 134 were on time. Okay. Of the 36 delayed flights, 12 were to destinations outside Europe. So that means 24 inside Europe. So as a skill to build up, you just sort of remember that there's additional information there. Now what we're going to do is put this all in a frequency table first. So assuming these numbers are representative of a particular day at the airport. Construct a frequency table. We're going to construct the frequency table here first, and then later on we will construct the probability table. So the first off, what we were told is that we have 170 flights. So make mention of that there, 170. Now, we were told that 107 were to Europe. Now, the 107 that were going to Europe were either on time or late. Altogether, there was 107. Additionally, we can figure out that there were 63 to outside Europe. Okay. Now, we were told that 36 overall were late, and that means that 134 were on time. So just as a remark, 107 plus 63, that's of that row, the total is 170. 134 and 36, again the column total there is 170. Now we were told the additional piece of information that 12 of the flights going outside of Europe were late. Actually, let's scroll back there and have a look at that again. So of the 36 delayed flights, 12 were to destinations outside Europe. So here we have it there. These are the 36 flights. 12 were going outside of Europe. That means that 24 were going into Europe. Now, what we're going to do is sort of, by the process of deduction, determine how many of the European flights left on time. Well, simply what number gives us adds to 24 to give us 107 as a total? The answer there is 83. Likewise, what number here gives us a column total of 63 when you add it to 12, and a row total of 134 when you add it to 83. The answer there is 51. So 51 of the non-European flights left on time. 12 of the non-European flights were left late. Likewise, 83 of the European flights left on time. 24 of them left late. We have these column totals that we know were given, and also these row totals that were also given. So everything there checks out. All that remains now is to put this in the context of a probability table. So essentially what we're going to do is, in each case, we're just going to divide by the total, 170. So I'm going to scroll down here to the probability. So essentially in the first instance here we have 83 divided by 170. That gives us, I'm going to 48.82%. Okay, I'm going to write it as a percentage. We have 24 out of 170. I'm just going to write that in. So it's 14.12%. This the 62.9 sorry 62.94%, 30%, 7.606%. That adds up to 37.06%. We have 100% here, and the column the row values are 78.82% and 21.18%. Now, just to be clear, where do all these numbers come from? I'll just scroll back to the frequency table. They are all these numbers divided by 170. So 12 divided by, and expressed as a percentage. So 12 divided by 170, expressed that as a percentage, we get 7.06%, and so on. And that ends